Let's go ahead and figure out how to write the formula for correlation. You'll see down here at the bottom of the spreadsheet, our same spreadsheet where we're looking at test scores and weekly TV hours watched per week, I have put an R for the correlation coefficient and an R squared for the coefficient of determination. I'm going to go ahead and put my cursor where I want the R to go. And as always, we start formulas with an equal sign. And the formula for correlation is C-O-R-R-E-L, and you'll see it writes it on the screen to help you. And then we want the left parentheses. And once we type the left parentheses, it shows us the structure of the function. And you'll see this one's a little bit different because it says array 1, comma, array 2. So rather than capturing one set of data, we need to capture two sets of data. That's because we're comparing TV scores and test scores and TV hours watched per week. So we need to get both of those sets of data. The way we do that is click and drag over the first set of data that we want, but then instead of doing the parentheses, we type a comma, and then we click and drag over the second set of data that we want. So now you see both sets of data are highlighted on the screen. Both sets of data are listed down here in our formula. We have B4 through B13, C4 through C13. So now we can type our closed parentheses and enter. And you'll see that our correlation coefficient, our R, is minus 0.6325287, which tells us that there is a strong, because it's 0.6, inverse relationship, because it's minus, between test scores and the number of hours watched per week, which means that as test scores go up, the hours of TV watched per week go down, and as test scores go down, the hours of TV watched per week go up. Now we don't know which causes which, because correlation is not causation, but at least we know there's a relationship. Let's go ahead and work on our R squared. Now, as I mentioned earlier, Excel doesn't have a formula to give us our R squared. There is no formula for the coefficient of determination, but it's pretty easy to figure out the R squared. The R squared is just R times R. So minus 0.6325287 times minus 0.6325287. So that's what we're going to do here. We're just going to make a formula from scratch. So we'll type an equal sign so Excel knows that we're starting a formula. And then rather than type all those numbers, we'll just click right on it. And you'll see Excel has entered B26. Now we need to type a multiplication sign, which is the asterisk, and then click again on our minus 0.26322587. So our formula here says B26 times B26, which is exactly what we want. We press the enter key, and you'll see our R squared, our coefficient of determination, is 0.40009256, which tells us that 40% of the variation in test scores can be explained by TV hours per week. It's not 100%, but it's darn near half. Now, the only other thing that I want to do is change the way these numbers look. These numbers are ugly, and no one else should be susceptible to looking at numbers this ugly. So what we're going to do is change the number of decimal places. I want to change both numbers at the same time, so I'm going to click and drag over both of them, and then go up to here where it says number, and then just make less decimal places, less decimal places. I'm going to bring it down to 2 decimal places because that's what I want. There's no real rule for it. So that is my correlation. So what I know from this is, what I can say from this is that there is a strong inverse relationship between test scores and the hours of television that the students watched, and that 40% of the variation in test scores can be explained by the number of television hours that they watched. Now, we don't need to go ahead and do it in this column because, we did both columns at once. That's the way correlation works. So we're done.